and then so I want to go with like Windows Server. So what I need to do is like, so I need to do this entire OS installation. So if I want to install like Ubuntu 18.0, 18 version or Red Hat latest version or Windows Server 2016 or 19. So I need to install the complete OS into this virtual machines. Like there is no escape, like, okay. So only problem here is like, so we are actually for running a small application, like a small application or deploying like a small application. So installing this entire Ubuntu OS or these OSs, so it is actually like space consuming as well as like resource consuming. Like the Ubuntu OS, it occupies like more RAM and all that stuff, right? So it's all resource consuming. Okay, so this is where like actually these containers they came into picture. So in the container, what happens is like so you'll have the same kind of architecture. Like so you'll have this host machine. So this is your host machine. On top of your host machine, like you'll have Docker installed. Okay, so you'll have Docker installed. And then instead of installing the entire OS, like so what we'll be doing is like so we can actually create containers. Okay. So just like this virtual machine, so you'll be able to create like containers. Okay. And these containers, they don't exactly have the entire OS. So let's say like I wanted to take this Ubuntu as a base container. Okay. So it doesn't actually contains the whole Ubuntu operating system. So it takes only the basic kernel of Ubuntu system, and then which is actually the minimal version of Ubuntu, which is actually required for running this particular container. No, the same is the case with Red Hat Linux or Windows Server. So it doesn't install the complete operating system. Okay. So this way, like we'll be able to save the resources. You know. So this is the basic architecture of Docker. Okay. So any questions? Yeah. No. No, okay.
Yeah, it's clear.
Okay, so you can see like, so this is the basic architecture. So now you can ask me like, so what is the actual necessity of a Docker container? So basically like, usually like this container, like the Docker containers, this analog, it came from this thing. Like, so the shipping containers. So if you see the shipping containers, so for example, like if I have a complex application which consists of a static website and then there are some background jobs and then there is a database and there are like multiple queues like Redis queues or RabbitMQ queue, and there is like an API applications or multiple services like microservices which consists of multiple APIs and applications. Okay. So if we want to deploy this complex application, so it requires like multiple softwares. So for example, like in order to deploy static websites, we need like Nginx 1.5, and then so these background workers, so they're running on Python 3.0. This is actually again running on the Ruby, and the database is PostgreSQL. This is Redis. So you can see like so in this small image itself, like you're seeing like many softwares. Okay. So if we want to deploy the same thing, like, so I'm just developing this on my development machine. Okay. And then, so I'm the only developer like who started working on this. So this is all good. Like now there is a person like who was added into the team. And then, so I wanted to deploy the same application onto his machine. So the first and the foremost problem what we see like as a developer is so we need to install the same versions of these softwares on the other machine. Okay. So which is again like a tedious job. So we have to keep track of all these softwares that we installed that we are using, and then so we need to make the exact replica. So even if we miss like a small thing, like obviously like it creates some issues on the other machine, like developer machine. So that is one of the major problems which we see with the deployments. So this also happens with the deployment of these applications into the development environment, QA environment, or the production environment. Okay. So we can miss like any config file or any of these software versions might change, or there can be like other unforeseen issues. Like so, for example, like here in my development environment, like I'm using Ubuntu 18, whereas like on the production environment, like I'm using like Ubuntu 20. So obviously, like so there will be a conflict, right? And we don't know like what what are all the problems it creates. Okay. So if we see the same thing, like, so if we can compare this with the regular thing, like, so for example, so if we want to compare with, so if we want to ship like any of these goods, so for example, like if we want to ship like the barrel of oil, or if we want to ship the cars, or whatever it is, like, so nowadays, like we see, like we have all these shipping containers. So all these shipping containers. So if you see, like you are not worried about the size of the shipping container, or how it is actually being transported, or what, how it is packaged, right? So your main goal is to ship these items. Like, so you want to ship these items, and then so you decided to go with the shipping containers. So, and how these containers are handled in different environments. So they are all predefined and standard. Like, so for example, like if we can use like all these tools, like, so they are equipped with machineries, so which can handle these containers, shipping containers, right? So in the same way, like if we go with like something like, so we can just put these all any of these items into the shipping container, and then so the other party, like, so they can simply handle this, and then ship them to different locations, right? Whether it is on the sea, or whether it is on the road, or on trains, right? So the same way, like if we want to deploy an application, so for example, like if we want to deploy a static applications into the development VM or QA server or production single prod server or whatever it is, like, so if we can have something similar, like, so if we can package it into a container or something like that on the uh, in the starting itself, like, so in the development phase itself, so we can actually take it forward, like in other environments also, right? For example, what I'll try to do is like, so in the Docker container, I'll just put this code, like the static website, along with all the softwares that are required to run this static website. So also the user DB, I'll put it in the Docker container. So with whatever the database I want, like whether it is like Postgres or SQL Server or what it is like. And also the queue, I can actually use like RabbitMQ, and then I can just put it like, so once I put all this all the required software into this container, so I can just ship this particular container, like I can ship this container to anyone in the team or anyone in the world, and they can simply run this container, and they'll be able to run all these softwares without installing any additional things, like, okay, so they are not supposed to be worried about what is the version of the Nginx I'm using, or what is the version of the OS I'm using, or any of these questions. Mm. So any questions with this?
No.
So, okay. So what is this like? So how do we actually do this? So this is all good, like when we see this image, like, but how do we put this, like, so how do we package the static website or a database or into these containers? So that like we'll be seeing shortly, like, so all these Docker containers and then images. Okay. So Docker is widely supported in almost all the platforms. Like, so wherever like you go, so you have a Docker support, like whether it is like AWS or DigitalOcean or Azure or GCP. So you'll have support for Docker. Okay. So what's the main theme for Docker? Like, so the main theme behind the Docker is like, so build once and run anywhere. Like, so whenever like you are actually building this, so in the development environment itself, like, so you can actually build these containers once, and then so you can take it forward. Like, so the same container can be used either in production or QA or your friend's machine or anyone's laptop. Okay. So it doesn't actually involve like so much of these resources, like I mean manual intervention of what software is supposed to be installed in other machines or anything like that. So it saves a lot of time. So for example, like, so you spend like almost 6 months in the development environment, and there are like multiple config related changes, and there are multiple changes which you are supposed to take it to the production environment. So unfortunately, like you forgot uh, to make a note of like few config changes or few config entries. So obviously, like, so when you're in production, so it will create an issue, and then you're supposed to spend some good amount of time in identifying what the issue is actually, and things like that, right? So, but here, like, so you'll build it, right? So whenever like you're making any config related changes or any changes, software related changes, so you'll put it in the container. And the container will be used for deploying into the production environment. Okay, so how does Docker actually work? Like we saw this, so we'll have the server. So this can be the host machine. So on top of this host machine, so for example, my laptop is the host machine. So on the host machine, so I'll have this host OS. So Windows is my host OS. So on top of Windows, like I'll have this Docker installed. Okay. So once this Docker is installed, like I can create like n number of containers. So each container can have like multiple apps running. And it has like, so the minimum binaries or libraries are required from the OS required. Okay. So for example, like if we want to take a Linux container, so it will have like only minimal binaries and libraries from this Linux environment. Okay, so which are required to run this particular application. It is not completely, we are not completely installing the OS into these containers. So this is the burden, like, so in VMs, like you'll have this guest OS installed on all those virtual machines. So which is actually a tedious job and then resource consuming. Okay. Um, so how does actually Docker work? So before that, like I wanted to show you something. So I wanted each one of you to create an account in this Docker Hub. Okay, so this is the Docker Hub. So many of us are familiar with these packages, right? So we are familiar with in the .NET world, like we have NuGet packages, and then in Java world, like so we have. So what is the Java? I mean, so in Java, what is the package manager? Like anyone can just help me. So in JavaScript, like we have npm packages, right? Similarly, like in Docker, we have this Docker image repositories. So this is like the public repo for Docker images. So you can actually see this. So you'll have images for almost all the softwares. So you can see like, so whatever, like if you want to go with like Ubuntu or Postgres or Nginx, Redis, Python, like you'll have images for almost all the softwares like which we use on a day-to-day basis. Okay. So what is the architecture of Docker? Like how Docker actually works? Okay. So basically, like we have something called as a Docker file. So a Docker file is nothing but like, so this is where like you'll have all the instructions that are actually that we wanted to have. So as I mentioned, like, so we wanted to package different softwares and then different code, right? So into a container or into an image, right? So this is where like Docker file comes into picture. So in the Docker file, like you'll put all the content, like so for example, like if you want to install Nginx server, like so you'll write all those commands for installing this Nginx server. And then so if you want to install Postgres database, so you'll write all those commands for Postgres installation into this Docker file. Okay. So once you have this Docker file, and this is how like a Docker file looks like. So this is a Docker file. So and we should actually follow the strict naming convention of Docker file. So you should have this Docker file, and then it doesn't have like any extension. So for example, like if I want to save a Docker file, okay, so I should actually save it something like this. So make sure that like you don't have any extension. And this is the Docker file. Okay. So it's just like a text file, like where you'll have all a series of instructions. Okay. So once you have this Docker file, so what you need to do is like, so you can issue a build command, like, so you can build an image from the Docker file. Okay. So if an image can be treated something like this. So for example, like you have, you want to install this like Windows OS. So basically, like what we do, so we'll get a copy of the OS in a CD or something like that, right? In a DVD or something. So the same way, like so once we build this Docker file, like it will actually create an image. Okay. So you can use this particular image, and then so you need to have this Docker engine installed on your host machine. So you can use the build command, like you can build an image from this Docker file. So using this image, like you can actually start it. Once you start an image, like so it will create a container. You know. So once you create a container, so you can again like push this particular container or image into the Docker registry. So a Docker registry is nothing but like, so this is the Docker hub. This is the public Docker registry. So any images, like you can push like multiple images. So for example, these are some of the images like which we pushed like so in the past. Okay. The same way, like you can also create images and then push them into the Docker hub. So once you push a particular image into the Docker hub, like so any of your friends, so they can actually pull that particular image and then they can run that particular image and create container out of that image on their host machine, on their laptops or on their virtual machines or wherever it is. Like okay. So this is the basic architecture of Docker. Like, so you'll have Docker file, and then using this Docker file, like you'll build an image. So, and once you build this image, like you can actually create a container out of this image. Like not only a one single container, you can create like n number of containers. And each of these containers, they run in isolation. Okay. So for example, like I have three different containers. Okay, so this is container one, container two, and container three, which was actually built from the same image. Okay, so for example, like this is in Unix. So by the way, like Nginx is server like which is used for static applications, static web applications deployment, like most commonly. But there are like other use cases also. So I'm creating like three different Nginx servers out of this particular three different. Okay, so these are like three different containers which were started from this Nginx image. Okay, so three of these containers they run in isolation. So for example, like if you make any changes in this container, so they don't actually reflect in the other container. Okay, so they all run in isolation. So we'll see them shortly. Like, but these are all independent containers. Okay, so you can treat them as like individual virtual machines kind of thing. So any questions with Docker architecture? So yeah, just ask me, like feel free. So even if you don't understand, like so we can actually discuss it.
Able to understand Pavan.
Okay.
That's good. Yeah, that's good. That's good.
Okay. So this is fine. So you're able to understand. I know, like, so majority of you don't have experience with Docker, right? So I just wanted to make sure that like you understand this.
Okay.
Just let me know if you have any questions so we can discuss like.
Okay.
Yeah. So these are the basic components. So the common terms like which we hear in Docker is like the Docker file and then so container. Container is nothing but like a running instance of an image. Okay. And then image is another name like which we hear commonly, most commonly, like, and then Docker registry. So Docker registry. So one of the Docker registries is like Docker Hub. The same way, like all of these cloud providers, like so Azure, AWS, or GCP, like they have their own private registries. Okay, so you can actually deploy to that, but you can just push this image to those private repositories and use them. Also, like it is not mandatory to always push an image to Docker Hub.
సో మన లోకల్లో క్రియేట్ చేసుకుని కూడా యూస్ చేయొచ్చు కదా, లైక్ Nginx లోకల్లో ఇన్స్టాల్ చేసుకొని, లైక్ ఇఫ్ ఐ వాంట్ Nginx సర్వర్, లోకల్లో Nginx ఇన్స్టాల్ చేసుకొని కాన్ఫిగరేషన్ సెట్ చేసుకుని
లోకల్లో అంటే లోకల్లో ఇమేజ్ క్రియేట్ చేయడం. Yeah, so we can actually, so it is not actually mandatory to push this particular image to the Docker container or registry. So if it is just for the local development purpose, so we can actually create an image like, so you can have a Docker file. If it is for a just like a development purpose, like, okay. So most of the companies, like what they do is like, so for example, like, so we were facing an issue, like, so when we are working with one of our clients, so they predominantly work on Ubuntu machines. Okay, so whereas like we were actually working on the Windows machines. So obviously, like, so these are like two different OSs and they don't have a mix and match at all, right? And so this is where like we were actually facing a lot of issues. So all the commands, like, so the code building commands or code, so the local development itself, like all the commands they use, like they are more specific to the Ubuntu environment, and we have to do a lot of tweaks to just solve that. Like, so that is where like Docker came into our rescue. Like what we did is like, so we tried deploying the code base into an Ubuntu container, and then all of the commands like they were using in the regular day-to-day development. So we were also able to use those commands. Like, so in that purpose, like, so we are just using, I mean, so Ubuntu, I mean, Docker for just the development purpose, like in the actual production, so they are not using this Docker. So this is just for the development purpose. So in that case, like you can actually have this Docker file committed to a GitHub repo or something like that. And then using this Docker file, like you can create like local images and then local containers on your laptop just for the development purpose. Okay. So it is not mandatory to push all these images to Docker container or image registry. Okay. Yeah, so that is more about Docker, like, so the basic architecture. So we saw the basic architecture of Docker and then how Docker actually works behind the scenes. Okay. So any questions, like, just let me know. So before actually getting started, like I assume like, so you all have a Docker installed on your Windows machine or whatever the OS like you're using, like whether it is like Ubuntu or Windows, like, so you all should have like Docker installed on your machine. So if it is like Windows, so you'll have something called as like Docker desktop. So it looks something like this. So this is the Docker desktop.
Else we have any container, virtual machines kind of thing to practice it.
Yeah, so virtual machine, so nothing comes for free, like obviously like virtual machine. So you need to create a virtual machine in any of the cloud environment and you need to
Yeah,
but there is
correct.
something called as Docker Playground.
Yeah, that is also there.
Yeah, so the Docker Playground, it also comes to a risk, like if we want to practice. So, but I suggest you to install a Docker on your machines, like Windows
So
machines or wherever it is.
it is volatile in 4 hours, right?
Yeah, so this is actually, I mean, so after 4 hours, like you'll lose all the data.
Yes.
So you can create like instance here, like, so this is just like a VM, so with predefined like Docker. So for using like Docker Playground, so you need to have a Docker account created. Well, also of course. So this is a Docker Playground. So you can actually see, so these VMs, like, so these instances, they come with like a pre-installed Docker. But I suggest like, so to go with like a Docker installation on your Windows machine. until and unless like you are not able to, I mean, if something is restricting you to do that. So I prefer installing Docker. Okay, so after installation of the Docker, so you can just check the you can check the installation by just issuing this command like Docker. So you'll see like multiple options, like you can also issue Docker -v, and it gives you the version of the Docker, like current version of the Docker. Okay. So you just go through this cheat sheet, like, so basically like what different commands, like different Docker related commands. Okay. So as we saw, like, so this is the architecture, right? Basic architecture. So we'll have a Docker file, and then we'll have we'll create a container and we'll push it to the Docker image. Okay. So it is not always required to have a Docker file to get started with Docker. Okay. So for example, like if I want to go ahead and then I want to play with this particular image. Okay. So I wanted to make use of this image, like Ubuntu image. Okay. So in this case, like the architecture slightly, I mean, so the way like we use these images, so it slightly differs. Okay. So here, like what we actually do is like, so we pull an image from the Docker registry, like this is the Docker registry, right? So we pull an image from this particular registry. And once we pull this image, like, so we'll issue few commands, like, so we'll issue commands, like we'll create containers out of this image. So we can create like multiple containers out of this image. Okay. And then on top of this containers, like you can actually make any changes inside these containers. And then you can again like push these containers, like you can create another image out of this container. And so basically, like once you create this image, like you can again push it back to Docker registry. Okay. And anyone else, they can actually pull this image and then they can work on it. So right now in our example, like I'll just go with this basic Ubuntu image. Okay. So every every image, like it has like good amount of documentation. So we can actually go through this documentation, and then we'll get like a lot of information from this thing. Okay. So the basic command to check like all the images that are present in our machine is Docker images. No. So this is used to list all the images that are downloaded into our machine. Like, so in my case, like I have all these images present in my machine. Okay. So for example, like here, if we see, so this is a fresh installation, right? We'll see Docker images. And you see there are no images that are present. Like, so it's an empty one. Whereas in my case, like there are multiple images that are actually present. So for example, like I wanted to run this Ubuntu image. Okay, so what I can actually do is, so I can just execute this command like docker pull and then the image name. So you can see like, so it is actually pulling this Ubuntu image. So by default, like what it does is like, so it tries to fetch all these images from the Docker hub itself. Like, okay. So if you have like a private repository, which is actually in AWS or Azure, so you need to configure, like, so you need to configure your console you need to configure your Docker such that like you pull those images from the private repository by providing username, password, or any tokens. Now let's issue this command like Docker images. So you can see this. I pulled like one image, like Ubuntu image, and this is the image. Like, okay. So now if I want to run this particular image, so what I need to do is like, so there is a command called as docker run. So this is the image name I should actually specify. Okay, so you're not seeing anything, right? So once this is actually, once we run this particular container, so what happens is, so you can actually see like what are all the containers using this command like docker ps. Okay, so there are no running containers here in this case. So you can also issue this command docker ps -a. So this will show all those commands like which were actually started and then which were killed, or different status, all the statuses. Okay, so you can see like, so this particular Ubuntu image, like whenever like when I ran this Ubuntu image, so it got created like 25 seconds ago, and then it exited like immediately, like okay. So, and what is the command that got executed? So this is the command that got executed. So again, I'll just run this with docker run Ubuntu. Okay, so you can see this. Okay. So Docker run. I'm just running this Ubuntu image again, like Docker run, and then I'm just issuing this command like echo Pavan. So this is echo is nothing but like I'm just trying to print this message like. Okay, so now again let's execute this Docker ps -c. So you can actually see previously, like it was executing the bash command. Now it executed this echo Pavan command, like so the command like which I provided with this container. Okay, so here like this container is getting, it's starting and then it is getting killed. So why it is getting killed? Because it doesn't have any job to do. So the container started and it has no job. So immediately it got stopped. Okay. So until and unless like a container has something to do, so it will like it will start and then it will kill. It gets killed immediately. So any questions here?
No problem.
No. Okay. Hmm. Uh, so I'll download this Docker image. Docker full image. So I downloaded this Ubuntu image, right? So Docker Ubuntu. So let me actually show you the concept of the basic concept, like so how these containers actually work. Like so I was actually mentioning that these containers, they are run in isolation, right? So Docker run. Okay. So you can actually see I just executed this command docker run the Ubuntu, and then I asked Docker to start this bin bash. Okay. So the bin bash is nothing but like, so just in Windows, like we'll have this shell, right? PowerShell in this command prompt, like the same way like the Linux has like a shell and then the bash. Okay. So I asked Docker to run this Ubuntu and then execute this bin bash. So you can see like after that I issued this command like docker ps. So once I issued this docker command like docker ps, so you're able to see this container, it is actually running. Okay. So this is the container that is actually running. So again, like if I run the same command, okay, and then again I do like docker ps, so you can see like, so another container it got created. So you're able to see this, right? So this is created 3 seconds ago, and this one got created like 55 seconds ago. So again, like if I run this command, like again, like I'm trying to run another container from this Ubuntu image. Okay. So you can see. So I have like 3 different containers that got created from this Ubuntu image. So it's like using this base image, like base Ubuntu image. So I'm creating like 3 different virtual machines kind of thing. Okay. So if I'll show you like how these containers they work in isolation. Okay. So for example, I'll just get inside this container. So what are all the commands like which we saw? So we saw Docker run, right? So we also saw Docker PS and then PS minus A. So PS minus A is nothing but to list all those containers which are in exited state as well as like running state. So Docker PS, it will show only the containers that are in running state. Okay. So I'll just get inside this container. So in order to get inside this container, so you'll have something called as Docker exec.
Interact with
Mhm.
the Docker exec -it. But
Yeah,
that is
you're able to see this command here, like you're not able to see this right here. So
no,
Docker,
yeah.
yeah, Docker exec minus. This is again like another command like which
Yeah.
we mostly use, like Docker exec.
Yeah.
So my Docker, so this is to run the command, like so run in the sense like so most of us are familiar with like either .NET or Java, right? So you'll have a class file. So until and unless like we create an object for that particular class file, so we'll not be able to access any of these properties or any of those methods that are present in the class file, right? So the same way, like the basic definition that we read about class file is like it's a blueprint kind of thing. And once you create an object for that, like that is when like you'll be able to access the properties or any content of this class file, right? The same way, like Docker image can be compared with a class file. So only when you run it and then create a container out of this image, like so that is when like so it can be used. Like or else like just having an image on your machine, so it doesn't help us out. Like only if you run that particular image and then create a container out of it, so then you'll be able to use it like. So now there are like 3 different Ubuntu images, right? So I just wanted to get inside this particular container. Like, so just assume that like these are like 3 different Ubuntu virtual machines. Okay. So I want to go inside this virtual machine. So I use like Docker exec minus -it and then container name. And then I need to specify what is the command like I want to execute. So I wanted to bin bash, like I wanted to start the bash shell. So now I'm inside this container. So you can see like anyone who is familiar with Ubuntu, so you'll understand like so root at the rate the container name here. Okay. So I'm on Windows machine and this is like the Ubuntu code. So now if I wanted to, so now I'm supposed to use all these Ubuntu commands over here because like I'm inside this Ubuntu VM. Okay, so I'll create a directory, mk directory Pavan 1. Okay, so I'll do ls. So you can see this Pavan 1, right? So I'll again like in another tab, what I'll try to do is like I'll just open, I'll get into another Windows, another Ubuntu container. Okay. Docker. Yes. Okay. So now I'll get inside this second container. Docker exec -it and then the container name /bin/bash. Okay. So if I do ls, so you'll not be able to see this thing like the file, the folder like which I created on the first machine on this container. Okay. So if I do ls here, so you can see Pavan 1. But here, like if I do ls, so I'll not be able to because so this is a second image. Like so previously, like I created a folder by getting into this container, like this virtual machine kind of thing. This container. So we should actually call it as a container. So I went inside this first container and there like I created a folder called as like Pavan 1. So now in this second PowerShell window, what I'm actually trying to do, so I got inside this container, like the second container. And here, like when I'm trying to find the same folder, so I'm not able to find that because So these are like independent things. So each container, like, so they don't actually share anything or anything like that. Like, so any changes made in one container, so they are specific to only that particular container. Okay, I'll create another folder. Pavan 2. So ls. So here, like, you'll be able to see in this container Pavan 2. So and here, like, I created Pavan 1. So and if I open like another PowerShell window, and if I just log into this command, this container, docker exec minus it, and then /bin/bash. And if you do ls, like, you'll not see either Pavan 1 or Pavan 2 because this is the third machine. Okay. So this is just a sample to show you, like, so how these containers, they work in isolation. Okay. So let's say, like, I'll um, okay, so I'll kill all these three containers. Okay, so I'll kill all these three containers. So in order to do that, the command is like docker rm. Rm is nothing but like remove docker rm. So I mostly use like -f. -f, like, you can use this to kill like even the running containers. Forcibly, like, I'm just killing these containers. Docker rm -f, and then the container ID. So it got deleted. So the same way, docker rm -f. You can also specify the first few characters of this container name. 5p, will just specify. Okay, so even this got deleted. Docker rm -50. Okay, it is not 35, it is 85. It is supposed to be. Yeah, even this got deleted. Now I'll just execute docker ps, and you can see, like, I have only these two containers running. So I'll also kill this. Docker rm -f. So I have only this container. This I'm using for a different purpose. Okay. So I deleted all these containers. Okay. So there are like multiple options. Like, if you want to delete like multiple containers at a time, so even you can provide like an option, something like this, docker rm -f dollar, and then the matching docker ps minus a minus q kind of. Yeah. Okay. So if you just give this command, like, so what this actually does is, like, so this is actually piping. So if I just execute this command docker ps -a -q, it gives me all those containers that are in running state. Okay. So you can also do grep related commands, and then so you can delete like specific containers, like with the regular expressions, I believe. Yeah. So since this is actually returning all those IDs, so the previous command, like docker ps docker docker rm -f, and then $. So this will output list of this container IDs, and that will be input to this docker rm -f. So it will delete all those containers. Okay. So now if I create like another container out of this image, like docker image. Okay. So I'm creating another container out of this docker image, like Ubuntu image. Okay. So docker ps again. If I do docker ps, so you can see this. Docker exec. I am getting inside this container, docker exec -it /bin/bash. So you can see, like, so none of those folders which I created in the past, like, so Pavan 1, Pavan 2, they don't exist. That is because, like, this is just like a fresh instance. Okay. So yeah, any questions? Yeah.
Like execute చేస్తున్నాం కదా, సో there is extension for Visual Studio Code. సో అది డాకర్ ఇమేజెస్ అన్ని కూడా రన్నింగ్ ఇమేజ్ అన్ని కూడా చూపిస్తాం. సో అక్కడ కూడా మనం ఎగ్జిక్యూట్
you can actually see that right now it is actually messed up.
ఓకే కంటైనర్ అయితే, సో దెన్ వీ కెన్ గెట్ ఇన్ టు దట్. ఓకే,
Container. Or else like if you are using like Windows this thing, like you'll be seeing that.
Containers అయితేనే సో ఇమేజ్ అయితే సో దిస్ ద
So
కమాండ్.
you can see all these commands like and all these images. So right now, like these are all the different images that are actually present. Like this is just like visual representation, but most of the time, like I prefer to go with like either Visual Studio or the Docker commands, like console commands. This feasibility, like we have it in Windows only, but in real time, like so we don't use like Windows.
మ్యాక్ ఆల్సో ఉంది డాకర్ అప్లికేషన్.
Desktop, yeah, Docker desktop, similar one, I believe. Okay, so this is how like we create like containers. So if we see the architecture, like what in this case, like what we did, so there is already an image that is actually submitted to Docker container by someone. Like so, this Docker Ubuntu image, like this is an official image. Okay, so you can actually identify like what are all the official images and then what are all like fan-made images. Okay, so these are all official images, like Python official images and Ubuntu official images. So official image is nothing but like the one like who is actually maintaining these softwares, like they upload these images. Okay. Uh, so someone like, I mean, some people from this Ubuntu, so what they did is like, so they created the Docker file and then they committed this particular image. They pushed that image to Docker registry. And in this case, like what we are actually doing, like we are pulling this image and then we are running that particular image and creating container out of this image. All right. So this part, like I demoed it right now. So this we didn't actually see. We'll see it at a later point. Okay. So any questions? So we saw this container Docker run, and we also saw Docker ps -a, and then we also saw Docker pull. So Docker logs is nothing but like, so if you want to see any logs in this container, okay, so you can just simply issue this command like Docker ps, right? So if you want to see logs inside this container, so for example, like I want to show you the logs in this container, interview builder, Docker logs. So you need to specify Docker logs and then the container ID. So you can see these are all the logs. Okay, inside this container. So Docker run, we also saw this command like, so Docker run. So if you want to create a container out of an image, like, so you can use this Docker run. And this hyphen name. So this is to specify the name for this container. So for example, most of the time, like when I do Docker run, Ubuntu bash. Docker PS, if I do Docker PS. So you can see the names. These are like randomly generated names. Okay. So if you want to have your own name, so you need to specify something like this. Hyphen name. So I want to specify Pavan underscore. Okay, so this is the name which I provided. Like, so if I execute this command again with the same name, so it will throw an exception. So it says that there is already a container with this name. So I'm just going somewhat fast because like we covered most of these commands like in the past 4 sessions. This is like an overview session, right? Okay. So I'll talk about this in tomorrow's session. And we also saw this like, so how to remove a specific container forcibly and then stop the containers with these commands. Okay. So if you want to stop a container, so for example, like Docker PS, so these are all the images, right? So I can, if I want to stop this container, so I can use like Docker stop. It's just like a VM, so turning off a VM. Docker, yes. So you'll not see that. Nothing. So you can also use Docker start. See, I'm able to start this command, start this mic. Okay. Stop, start. These are the images. Like so to list an image, like we can use this command like Docker images. And if I want to delete like any images, so Docker images. So if I just wanted to delete this Ubuntu image, so I can use this ID or this Ubuntu Docker RMI. So if there are any containers that are actually running, so it will throw you an error. So for example, like here, like error response from daemon, unable to remove repository reference Ubuntu container. So and so container is using its reference image. Okay. So if a container is running out of this image, so it will not, you'll not be able to delete using that command. But if you use like force command like -f, so if you use this option, so it will delete, it will stop the container, and at the same time, like it will delete this image also. So this is like a Docker image, like so Docker push, like we'll see sometime later. Okay. So for today, like I'll stop it here. Like so, it's almost like 4:30. Like so, any questions or anything to discuss? Like just let me know. Since we have like another 5-10 minutes, like we can just discuss on what we learned today or any questions.
One.
Hmm.
One actually, we use Docker attach in the second session. So, what's the basic difference between the Docker attach and Docker execute commands?
Um, so Docker attack. So basically, like so Docker exec. One thing.
For this starting
So
purpose, we are using Docker bin dash, and
hmm,
already it is in a running state. We can attach directly there.
you can attach it like so, or else
Yes.
like I can also use this Docker exec -it and then
At least
so
dash.
it is asking you for the command. Like so, for example, like if you
Correct.
see, so Docker exec requires at least 2 arguments. It is something like Docker exec. It needs the container name and then the command and then the arguments. Okay. So if you see, there is something called as like an entry point, and then there is a command concept, like so, which we can cover it later point of time. But just for your for answering your question, like I'm just so if you see this, like if I issue this command like Docker exec, so -it is nothing but like it is interactive mode. So interactive mode is like, so you want to get inside the container or interact with it. Okay. So when you specify like Docker exec -it and then the command and and then the container ID, so it is asking, so we should actually provide the command. Okay. So it's not just sufficient to provide the container name. So we should also provide the command. Okay. So what I can actually do is, so I can simply do Docker exec -it, and then I can say like echo one. Okay. It's not funny.
Pawan, sorry to interrupt. So, my main observation is like Docker attach and Docker exec is like running the container foreground and background. So
Correct,
No,
exactly.
so not
Exactly.
exactly. So you can actually see. So for example, when I did like Docker exec minus IT, and then so here like it is forcing me to provide the command. Okay. So command is nothing but like it can be any command. Like so here I'm just specifying like echo Pavan. So it is just like I'm just passing echo Pavan. So this is the command I'm passing. Like whereas Docker attach, what it does is like so there is already an entry point command which is present with this, which is actually available. Like so for example, like when you do Docker PS, okay. So you can see like this is the command like which is already executing. Okay. So when I try to
Yes.
do an attach, so Docker attach, and then the command, so it takes me to this command, like it continues with this existing command which is running, which is already running. Okay. So whereas like with exec, you need to provide an additional command. So it is not something like so you need to so this can be used to get into the container or so. For example, like if I
First
give
time.
like yeah, so if I give like Docker. So if I give like docker exec slash bin slash bash, so it will take me inside this content. Oh, it is not running. Sorry, using the same old one. Docker exec minus it slash bin slash. So for foreground and background, like you'll have detach option. Minus D option is for foreground and background. So you see this, right? So the same command, like if I use like docker exec minus it and then the container ID, and I'm asking to execute this bin bash. Okay, so it is taking me to bin bash. So if I issue like echo, so it is just echoing this. So whatever the command like which I provide, so it is actually doing that. So whereas with Docker attach, so that is not the option. So I okay, so the Docker attach
Yes.
requires exactly one argument. So you cannot actually pass an argument to Docker attach. Like so it is just like to get inside this container or attaching the container. That's it. Like whereas with Docker exec, like you'll be able to pass like the commands, like any additional command. Like it's not just for getting inside the container. So it can be used for executing like any other commands also.
Like running a bash or something. So you
Yeah,
can
so in this case, like since this is like a basic Ubuntu container, so I'm just able to show you only these two commands, like bin bash and then echo. No,
Yeah, what my understanding is, suppose there are three containers, so C1, C2, C3, let's say, and we're supposed to switching one to another. We can use that Docker attach C1 and Control P, Control Q, and again we can go into another one like Docker attach C2 kind of thing. In that case, we can use the already it is in a running state. That is what
yeah,
I'm trying to say.
so
Yeah.
yeah, I mean, so not just to get inside this container, but this is the main difference. Like so, the
Correct.
command part,
Correct.
like so,
Yeah.
you can
Yeah. Correct.
you can issue like any command to Docker exec, whereas with attach, like it is just for running the existing command like that.
Yes.
Okay, so I'm not sure like who asked this question. Like, just let me know like your name, so I'll get an idea. So did I answer your question like Docker exec and then Docker attach? Okay. So any other questions?
Hello.
Yeah.
Hello. Uh, What's the difference between Docker attach and Docker start?
Docker start is just to start a container. Docker start, for example, like So if there is a container which is in stopped state, so in order to start that container, so you'll use a Docker attach. Like, so for example, like if I give like Docker start and then this container, so this is already running container 38064, right? So it just output. So it doesn't actually, it is just to start a container, like a stopped container. So your question can be something like this. So what is the difference between Docker attach and Docker run kind of? So for example, like, so Docker start is just to start a stopped container. Okay. So for example, like if I wanted to do Docker run -it and then my Ubuntu image name and then bin/bash. So even in this case, so I'm okay. I deleted this. Yeah. So even in this case, like, so I'm just issuing this command. Like in this case, what I'm actually doing, so I'm creating a container out of this image using the run command. Okay. And then, so at the same time, like I'm issuing this command, like I'm saying like I want to interact with the container using this command, like bin bash. Okay. So what it does, so initially, like it is doing like multiple things. So initially what it did, so when I issued this run command, so it said like unable to find this image like Ubuntu latest locally. So I deleted that image, right? RM. So initially what it does, like it is pulling this image, like, so that means like it is issuing Docker pull Ubuntu. So that is the command like which it executed. And after that, like it started this, it ran this container and then it attached this particular, it went inside this container. Okay. So did I answer your question, like difference between start and then attach? Like start is just to start a stopped container. So if I start this like Docker, yes. So for example, 8.8, this container is in running state, right? I'll stop it, Docker stop. Okay, so I stopped this container. Right? Okay, so I stopped this container. So you can execute like Docker ps. So previously, like you're seeing this container in running state, but now it is in stopped state. So you'll not be seeing that container 8.8 that container. Okay. So now if I want to start this same container, okay, so now I'll issue like Docker start. Again, now I can do Docker ps. So you'll be able to see that container clearly. Okay. So yeah, any other questions? So I think like so this is like a fast forward session of the last 4 sessions. Like hope like you'll be able to catch it up. So no other questions?
Yeah.
So even
It's very nice, actually.
Yeah.
It's a great
Thank
session
you.
and nicely presented.
Thank you. So even if you have any questions, like so if you're not able to understand the architecture or anything like that, like you can just ask me, and we have like another 4 minutes. Like let's wrap it up at like 6:45, 4:45. Okay then. So I think like we don't have any questions. Thank you.
Yes.
Thank you everyone. Thanks for your time
Yeah.
then. Bye.
Yeah.
Thank you. Thank you all. Bye.
Thank you all. Thank you very much.
Thank you all.